Okay. So we are getting the live stream link for those who are not able to join in now. So in a couple of minutes, I'm going to be sharing my screen right now so that the chemistry folks I don't expect that my dear chemistry family will be the ones doing this to me. We are getting the live stream link for okay, let me able to join. Yeah. I'm going to put it on the WhatsApp chat. Can you see my screen now? Can you see my screen?
Yes, we can see it very clear. Yes, you can see it.
Okay. So in a couple of minutes, I'm going to be sharing my screen right now so that the chemistry folks don't expect that their chemistry family be the ones doing this to me.
Oh.
Yeah, that's what I'm processing. Okay, let's yeah. Yeah. I'm going to put it on the WhatsApp chat. Can you see my screen now? Okay. Who's starting now? Can you see my screen? Yes, that's it. All right. Yeah. Our presenter can start now.
Hello, ma'am.
Yes. Okay. You have the floor. So
Okay.
in a couple of minutes, I'm going to be sharing my screen right now so that the chemistry folks.
My name is Ambrose, Mrs. Ambrose Adenike from Education District 6. So I'm representing the chemistry group.
Hold on. Hold on. I need to stop that.
Yeah.
Hold on.
Okay, ma'am. Can I go on?
One moment. So I want to share the screen back up. I'm sharing the screen and I want the slide to be on slideshow. Yes. Are we good now? Yes. Mrs. Ambrose, you are good, ma.
I hope I'm audible now. Can you hear me clearly?
Yes, please.
Yes. My name is Mrs. Ambrose Adenike from Education District 6. So I'm representing the old chemistry teacher and selected for the space education program. That's a training. Now I want to really appreciate Dr. Banke Adeusi for giving us a second chance anyway. For the chemistry settings, we want to run the chemistry of space metals. When you're talking about space, you must to talk about chemistry. You must talk about metals. Now, chemistry of space metals by group chemistry group district 6. We want to run today. I think today is 4th of 9th. So it was prepared on the 2nd. Anyway, so we are presenting it today, which is 4th of September 2024. Now, our objectives, what are metals? As we know, teachers, state the types of metals and their examples. Now, common metals used in the space exploration. Of course, when we talk about space exploration, we must talk about metals. Now, understand the properties of metals in space exploration, the properties of metals in space exploration, then understand how atmospheric conditions affect metals in space exploration. I want to also appreciate Mrs. Olusa for presenting. She's the one that prepared these slides. Now, going on, the keywords that we're going to use here, we had ionization, the process by which an atom or a molecule acquires a negative or positive charge by gaining or losing electron. Now we have corrosion. Of course, metals can corrode even in space. The process by which metals deteriorate through gaining of oxygen. I'm on the third slide now. Now we have a spacecraft, a vehicle designed to explore, study, or travel through space. That means that there is a vehicle that is being designed to explore and travel through the space. And I'm very sure that vehicle will use chemicals to move, probably. Now, radiation, energy emitted from electromagnetic waves. Then we have durability, ability of the materials to withstand wear and tear over time. Then the density, the measure of mass of substance per unit volume. Now, when we think about sending a spacecraft, that's a diagram of an astronaut there. When we think about sending a spacecraft to another planet or space, we ask questions like, how will he get to the destination? But when was the last time we asked, what will it be made of? What we are sending to the space, what material will it be made of? Will it be made of metals? Now, this question is important as the material we should need to be suitable for the mission goals and locations in the space. Very important. Now, when we come to what? Definition of a metal. Say a metal is an element whose atom ionized by electron loss. Now, look at the diagram there. A metal is a material that is typically hard, opaque, shining, and has good electrical and thermal conductivity. Now, what are the types of metals that we know as science teachers? We have the alkaline metals. Those are the group 1 elements. We have the alkaline earth metals. Those are the group 2. Those are the metals you see them in space, being useful in space. Now, transition metals are there. Those are the group D elements. We have the lanthanide series and the actinide series, which are the group F elements. So these are the elements you want to look at and what is the chemistry of what space elements. How are these elements useful in the space or during space exploration? Now, common metals in space exploration. These metals are what? We have one, aluminum. It's a structural component, fuel tanks, and radiation shielding. So they are common metals in space exploration. Now, so these are the metals we can get from what? When we explore the space. Titanium is there. It has high strength, low weight components like fasteners and engine parts. Then we have the stainless steel. It's corrosion resistant component. It's like what? Hardware and storage container that it can be used in the space. Now, copper is there. Electrical wire. You can imagine that there is the car that could move even on the space. Now, electrical wires of a car, what can be used? We can have copper as being used there and cycled. Now, silver, coating of radiation shielding and thermal. While the astronauts are going on the space, the radiation shielding, silver coating, it helps to coat it. Now, gold, coating for radiation also, thermal control and electrical contact. Then we have the beryllium there, which is beryllium is number 4 on the periodic table. It's a lightweight, high strength component like satellite structures and mirrors. We have the INVA, the low expansion alloy, is an alloy. Now, nickel-based alloys are also there. We have the high temperature components like engine nozzles and heat exchangers. These are elements that we can get from what? The exploration in space. Now, properties of metals in space exploration. They have properties. Now, they have high strength to weight ratio. We have the metals like titanium, aluminum, beryllium, offer exceptional strength while minimizing weight. So when we talk about space, we talk about the usefulness of what? Metals, usefulness of what? Chemistry in particular. So there's nothing we could talk about space that will not talk about chemistry. Very important. Now, corrosion resistance. Those are the properties of metals there. Stainless steel, silver is there, gold is there. It resists corrosion from harsh space environment. There could be harsh space in the space. Now, what does it do? That it has what? A soft of what? Resistance. Now, high melting point. Metals like tungsten and rhenium withstand extreme temperatures. We all know the temperatures in the space. Now, low thermal expansion. Even other alloys maintain their shapes and size across temperature fluctuation. It helps it. Now, high conductivity. Copper and silver facilitate efficient electrical connections. Of course, electrical connections is being done with copper and silver. Then we have the radiation resistance. Lead, silver, gold, and gold provide shielding against harmful radiation. You know that if there's too much harmful radiation with a spaceman, what happened to him? Even despite his gadget, what happened? It could result into cancer. So what happened is that the radiation, there's a resistance against radiation, which all these elements have been said they provide shielding against harmful radiation. Now, low reactivity. We have metals like titanium and stainless steel resist reaction with other elements. Now, high ductility. Metals like copper and aluminum can withstand stress and deformation. Now, resistance to fatigue. Metals like titanium and stainless steel maintain their strength over time. I hope you're with me.
Yes, ma'am.
Am I audible?
Yes,
Now, cryogenic properties. So metals like aluminum and stainless steel retain their strength at extremely low temperature. Now we have atmospheric condition and metals in space. Look at them. Look at atmospheric condition, Doctor, atmospheric conditions and metals in space.
Next slide, right?
Yes. We'll move next slide. Next slide. Atmospheric conditions and matter in space. Next slide. Yes. Now, atmospheric condition matters in space because we have to. It must be measured. Now, this atmospheric condition in space can significantly impact matters due to the harsh and unique environment. Definitely in space, we can have harsh and unique environment. Now, there's a vacuum. The space is a vacuum, which means there's no air to provide oxidation resistance or lubrication. So metal can outgas, leading to surface changes and contamination. Now we have radiation. The high energy particles and ultraviolet radiation can cause metal degradation and embrittlement and increase electrical conductivity. Look at the spaceman there. So the radiation could be so much for him. Then we have corrosion. So in the presence of moisture or contaminants, metals can corrode even in space, low humidity environment. You could see it. You could see the movement of the would you call it? It's not a car there. We call it a spaceship. Now, extreme temperature. Temperatures in space can range from -270 degrees centigrade to 120 degrees centigrade. Now, causing metals expansion, contraction, and potential failure. Now, what do we mean by that? Chemistry of what? Space elements. Now, causing metal expansion, contraction, and potential failure, which could affect the astronaut. You could see the wall of the space there. There's corrosion. Corrosion has taken place. Now, it's that extreme temperature. That's -270 degrees to 120 degrees centigrade. So it should be cautioned. So as chemists, we need these metals are there in the space. So when I tell you that we have a lot of them, and there is no how an astronaut or will go to the what? To the space, or an engineer will go to the space without what? Taking effect of these metals. So in summary, space metals are selected based on chemicals and mechanical properties. Harsh environmental conditions can affect the properties of metals. Then aluminum, titanium, copper, gold, silver, stainless steel, beryllium are common metals in use in space exploration. And finally, in the realm of space exploration, a variety of elements are used, but most significantly are hydrogen and oxygen for rocket fuel. We use hydrogen for rocket fuel. Now, hydrogen serves as the fuel, while oxygen acts as the oxidizer, creating a powerful explosion when combined to thrust rockets in space. Thank you, Mrs. Dr. Banker.
You want to go through your activities?
Okay.
Yeah, we have the activity slide.
Okay. So we have defined metals. That's the activity slide there. We have defined metals. Give two types of metals with example. Now, can I ask anyone, can they define metals? We said describe how atmospheric conditions affect metals in space.
Okay, here is the summary.
Yes, I've talked about the summary. I've talked about the summary.
And that's it. Right. So can I stop share now?
Yes, ma'am. Thank you, ma'am.
You're welcome. Okay, we are back. We are back. Any questions? So the goal of this exercise is to give you a kind of demonstration, activity demonstration, so that when you get back to your classes, you will be able to implement them. You will definitely have topics within the scheme of work that you can integrate aspects of space science into when you are teaching that topic. So it's not that you will have a different curriculum. No, it's just infusing it into what is already existing in our current scheme of work. And we don't want our students left behind. We don't. The technology is advancing rapidly. Science is dynamic. Before, you hear that you can use olive oil in the hospital. Now they say no use of olive oil and all that. So science is advancing, and we don't want to keep teaching those old information in this jet age, right? So that if you want to teach any topic, even the periodic table is a topic SS2 first term. In SS1, 2, we have hydrocarbons, you know, so many topics in chemistry that we can infuse space science. So that's to give you a kind of overview so that you will be able to do this on your own when you get back to class. And of course, we have our community of teachers. If you have questions, if there is a topic you want to plan with space science infused in it, and you don't know how to go about it, just put it on your WhatsApp platform. Get active. Let's have these conversations going. That's why we are a group and not leaving it out to just one individual to do, right? Thank you, Mrs. Ambrose, for your fantastic presentation. Does anyone have questions, comments, contribution? And we can do that in 1 minute. Do we have any? If you do, you can just raise your hand, and because this is a final presentation for the day, and we'll go back home to prepare for resumption. All right. Okay, so this is the favorite part where we take group pictures, and you can turn on your camera if you are in a good place, and we can take the group picture. Yeah. Where is Mrs. Ambrose? Mrs. Ambrose should not be absent at this group picture. Mrs. Ambrose, this is not a time to be absent. Okay. Get ready, wear your biggest smile, you know, smile, smile. Pose for the camera. Let's have a pretty one. Oh. Is somebody else taking from out there? If you are taking, please, you can also take for us and post it on the group platform. Okay. Team chemistry. So here we go. 3, 2, 1. One more. Yeah, let me see. Thumbs up. Three, 2, 1. Taking. All right. This is how we wrap it all up. So we can now expect our questions and continue the conversation back on WhatsApp, right? All right. Do all have a great day and enjoy the rest of your day. The meeting is now ended.
Thank you, ma.
Want to say anything? Feel free.
Thank you, ma.
Thank you for coming.